This is a design example. We're going to design an op-amp-based circuit to produce a function V0 that is a 5V1 minus 4V2. So the first step is to come up with a possible solution analysis. The best way that you can come up with a solution is to get familiar with the typical application that we have. Just by looking at the combination, so one signal have a positive coefficient, the other signal have a negative coefficient. So it implies that we have a V1 and V2 connected to two different terminals of the op-amp. At the same time, the coefficient for V1 that is greater than the coefficient for V2 by 1. We know that the resistor network that will be set up connected to the V2. So here's our op-amp. That is the V0. We know that we have to have V1 somehow connected to the non-inverting terminal. And at the same time, we have the V2 is connected to the inverting terminal, but with the resistor network set up. So this is the initial design that we come up with. And let's call this resistor R1, this resistor R2. So we know that by giving this design, eventually VO that should be equal to some coefficient times V1 minus some coefficient times V2. And a coefficient for V1 that is greater than that of V2 by number 1. So step 2 is to obtain the design equations. So we're going to use ideal op-amp model for this. The ideal op-amp model tells us V plus that is equal to V minus, and I plus that is equal to I minus that is equal to 0. Since V plus that is equal to V1, so we know that V minus that is also equal to V1. Now we can obtain the KCL equation at the inverting terminal. We have a V2 minus V1 divided by R1 plus V0 minus V1 divided by R2 that is equal to 0. Now we can find the output of V0 in terms of V1 and V2. So we find a V0 that is equal to 1 plus R2 over R1 times V1 minus R2 over R1 times V2. And step 3 is we're going to find the conclusion. By comparing this design equation to what's desired, we know that R2 over R1 that is equal to 4. Or we are going to select R2 as 4 times of R1. So we have two resistors to select, but there is only one constraint to satisfy. So it means that you have multiple solutions. As long as you select R1, you can select R2.